The system is changed. I feel it in the backlog. I feel it in the design. I smell it in the pull requests. Much that once was is legacy, for none now code who remember it. It began with the forging of the great services to manage ship cruising. 3 business domains were given to the search team. Everlasting, marvelously straightforward, and certainly the first pioneers, at least in their own esteemed opinion. 7 to the post-booking team, trend seekers, wise admirers, and devoted followers of fleeting glory. And 9 domains were given to the modernization task force, who above all else desired power. For within these domains was bound the strength and the will to govern each value stream. But they were all of them deceived, for a universal ubiquitous language was made. High in his ivory tower, in the fires of Mount Togath, the lead architect Sauron forged a master model. And into this model he poured his compulsion for control, his obsession with uniformity, and his will to standardize all life. One model to rule them all, one model to shape them, one model to bring them all, and in the big ball of mud bind them, in the land of design dead, where the shadows lie.
Sorry about it, guys. But the good news is that at least I finally fixed this bug. So now when we're searching for ship cruising that are, we won't be seeing the ones that are departing in the past. Although it took quite a lot of time and I had to touch stuff all over my model, so I wonder if there was a better way.
We did it right. Yes, precious. Clearly. This was the right solution. Yes.
You're right, Precious. My model is great. Let's send that to production. What?
The monitoring dashboard show critical regression on the booking history feature.
I didn't touch that.
We are quite sure the problem comes from your last deployment. Let's review the response of your API together.
Sure, if you want. Here it is.
OK. Oh, I didn't realize that your model has grown that much. Last time I checked, you were handling only the search. And now it looks like you just dumped there the selection concern and the booking concern in the search model of cruising. It's a total mess.
Come on, it's not that bad. It's just the business domain is complex, not the code in itself.
Jealous. Yes. Jealous of our modeling skills, Precious. She envies us, he does. Nasty, tricky, jealous developer.
Don't worry about it. I understand this domain, and I know how to fix these failing concerns. There you go.
Oh, but what did you do? you just broke here the see previous day ship feature, which allowed user to check for earlier departures.
OK, I know how to fix that. Don't worry. There you go.
OK, but OK, you just introduced even more regressions.
OK, I know how to fix that. Don't worry.
But stop. You just updated half of your model and 90% of your tests. Do you still understand what's happening with your model?
Well,
because
OK, you're pushing me right now, but give me 2-3 days. I'll run my model refinement process, and I'll fix all those failing cases. Don't worry.
So can't you see it's already a big ball of mud full of coupling?
A big ball of mud? No.
Sorry, there's a little problem there. OK. Yeah. So like I say, given all these changes, do you still understand what's going on within your model? So,
no, as I told you, I'll just run my refinement process, and don't worry, I'll be fine.
OK, but what is that process?
Well, it's a recursive process. I always go from the business needs. For example, in the case of the MVP, it was searching for ship cruises, which drives the phase of exploration and experimentation, event storming, prototypes, and so on, which in turn shapes a model. Now, this model needs to account for new business need, rather.
Yeah.
For example, selection of a ship's fare, so that we can see the price that it will have, and so on. Which drive another phase of exploration, shape a new version of the model, and so on and so on. You know, basic stuff, so model exploration whirlpool.
But it's not model exploration whirlpool. You kept stacking changes onto your existing model creating so much coupling that it's starting to collapse under its own weight. Your model exploration whirlpool turned into model sinking because you focus solely on creating solutions within your existing model, overlooking the possibility it may have become obsolete.
Obsolete?
No, no, the model is not obsolete, Precious. A precious model, yes, is made to last, made to stay with us for a long, long time.
The model is not obsolete. I created it to be extensible and adaptable.
But a model is only valid for a specific problem for a limited period of time. If it appears extensible, it's only by chance. It depends on how your new problem relates to the one you already solved.
Now, but during my exploration whirlpool, I run an event storming to make sure that my model could account for these new features, so it's not a problem.
Okay, but the model exploration whirlpool is meant to help discover suitable models, not to trap teams in confirmation bias. A model should be challenged, not reused by default. Sometimes adding a new feature requires depreciating your existing model and shaping a new one.
No, 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 Precious. We refine this model, yes. Refines it lots. We can still adapt it, Precious.
Now, we can't start over from a new model every time. We know we have to leverage the work that's already been invested in the design because one does not simply challenge the model. We can't afford not using its power.
We can't use its power. It's a burden that is holding us down.
A burden? What burden? Look, I started with this model, which is very simple, right, to handle searches.
Yes.
All I had to do to handle the selection concern was to add a few fields and a bunch of code. And it's the same for the booking. I tell you, this model is extensible and flexible.
It's so flexible that I came to see you after you broke the booking history feature while trying to fix a bug in the search.
That happens.
But continuously adding feature without challenging the model only creates accidental design debt.
Accidental what?
So accidental design debt. It results from decisions that inadvertently introduce coupling in models, lower their cohesion and flexibility, increase their complexity, and erode their correctness. And this accidental design debt will manifest as complexity within your model.
Yeah, that's interesting, but I don't think my model is affected at all.
You know, I've been watching all the issues you had lately, and I think it's even worse than that.
What do you mean?
The bug appears in part of the model you didn't even touch.
Well, I did just break the production this way.
Have you ever made a simple change and had to tweak things everywhere in the model?
You've seen the last pull request.
Exactly. And have you noticed it's taking you longer and longer to develop a new feature?
It's true that shareholders are constantly on my back because of that.
These are symptoms showing that your model is resistant to change because it has accumulated the accidental design debt. Clear signs that the model is now affected by entropy.
Entropy?
Yes. So this is the degree of design disorder within your model. The higher the entropy, the less the model is coherent, consistent, and cohesive. It loses its ability to create clear outcomes without unexpected regressions. And design effort is dissipating on navigating accidental complexity, and your cognitive energy is wasting instead of turning into business value.
Okay, so what you're saying is that this accidental design debt will accumulate and produce through this accumulation some model entropy.
Exactly.
And eventually, over time, it will dissipate the structure and the clarity of the model.
And even more than that, the consequence is that it will degrade the quality of our decision, leading to even more accidental design debt. And business concerns eventually becomes so entangled that their boundary disappears and a big ball of mud takes shape. Stacking changes in a model affected by entropy slowly makes it harder and harder to change. Even minor modifications become prohibitively costly and prone to unexpected regressions. At this point, you could say that the model has sclerosed, a clear sign that you're losing control. And this sclerosis is locking down the model into its big ball of mud shape. Most modernization attempts will fail. Regaining control requires huge effort.
Okay, that's interesting in theory and all, but you know, in practice it's different. And with my model in particular, it's different. This has nothing to do with it.
Okay, so let's take a look at your model. So here, you're trying to address both the search and the booking, two orthogonal problems within the same model.
Yep.
What makes you think they belong to the same bounded context?
Because all I have to do for it is just to make a quick refactor here. It's easy.
You know, all these developer habits we have, refactoring, KISS, don't repeat yourself, YAGNI, must be set aside when we design models. They push you to reusing your existing models instead of letting it go.
Let's go. No, we can't process. We need it. We loves it.
I can't afford to challenge a model now, not with all the deadline coming up, and especially not after all the time I spent refining it.
But unfortunately, all those things will lead you to create intrinsic coupling within your model.
Intrinsic coupling? How can a model be coupled to itself?
By trying to solve several problems at once. You merge here multiple implicit models into a single one. And in fact, what you created as a name, that's the spork effect.
Wait, are you comparing my model to this implement that attempts to take both the role of a fork and a spoon at the same time and fails miserably at both?
Exactly.
That's extremely insulting.
So it usually happens when you reuse an existing solution to a problem for which it wasn't originally designed. And that's the most common form of intrinsic coupling. With a spork model, you have to understand a larger multipurpose model every time you make a change to avoid regression. And that's why, by nature, a spork model is fragile. And over time, as a fragile model breaks more and more easily, you become reluctant to change it, because it has become rigid. The only option you have is to add new elements without touching what already exists. And all those things are increasing the entropy of your model, and therefore your cognitive load.
OK, so several implicit models within the same model. You're saying that microservices is the way.
No, microservices. Good idea. And then we can put the precious model in a shared kernel inside a library. Or even better, in a shared database.
Wait, shared database? Not listening. Not listening.
Who are you talking to?
No one, don't worry.
No, microservices are just a deployment strategy. What you really need here is to let distinct models for the search and the booking emerge by resolving the accidental design depth within your model.
Wait, split in distinct model? But I'm not even sure where the accidental design depth will be in my model.
I will teach you how to spot it, come on. So look here. When you added the booked Boolean in the search model to handle the booking feature, you created here a model tension.
Models have tensions now?
Yeah, they have tensions. So a model tension is the result of accidental design depth, and that may induce some intrinsic coupling within your model. It's a structural stress within a model that signals it is being stretched beyond its conceptual integrity.
So the conceptual integrity here will be the opposing force of model entropy, right?
Yes.
So given the definition you gave of model entropy, I guess conceptual integrity is the degree to which a model maintains clarity, coherency, and cohesion.
And its purpose.
So this conceptual integrity will prevent accidental design depths, but the model tensions will erode the conceptual integrity, right? It's true that I may have slightly degraded the coherency and the purpose of the search model by adding this booked Boolean right there. But I had to do it this way because I did the same thing with the selected Boolean here when I handled the selection concern. So if I change my approach now, I would have needed to make a deep refactoring of this concern.
So without realizing it, you just admitted that the previous change you made was already a model tension on which you built the booking feature. And I didn't mention that before, but in your spork model, you have entangled also an implicit model for the selection. By adding here a selected Boolean in the search, you created a model tension. But since here you left this one unresolved, it eventually crystallized. So the tension becomes so entrenched that resolving would require a costly redesign, affecting more business concerns than expected.
OK, so you mean that when a model tension crystallizes, it becomes a structuring constraint of the model?
Yeah, you mentioned it yourself. It constrains you in the way you develop the booking feature. And this crystallized tension compromised the conceptual integrity of your model.
Which means that crystallized model tension raised entropy.
And even worse, they shape the model sclerosis since they increase the rigidity of your model.
So that means we need to do something about them before they crystallize.
Absolutely. All these are symptoms that your model became obsolete. Spotting a model tension early will allow you to resolve it before it crystallizes. So you can use them as signals of accidental design depth. Now you know how to spot it. You can create distinct models for the search, the selection, and the booking.
We knows the truth, precious. Only a large language model can solve this. So big, so clever, so precious.
Wait, an LLM? I don't want to be a slave of dogma and hypes anymore.
But who are you talking to?
No one.
Oh, I see. You're under the influence of this unique model. Throw it to the fire. We need to make the implicit model explicit.
Go away and never come back.
No!
Are you okay?
I'm not sure I can handle it anymore. I carried this big ball of mud too long.
Okay, so let's just be rid of it once and for all. Come on, I can carry the model for you, but I can't carry you.
Wait, what?
Okay, let's review the event storming you did for the selection feature.
Just say it like this next time then. Okay, so when a user selects a fare on a ship, When a user selects a fare on a ship, we have to check the completion of the selected fares, and we also need to compute the total price of the selected fares.
I think you overlooked some important information within your event storming there.
Like what?
Like here, you're computing the total price. What total price are you computing again?
Well, the one of the selected fare. As I told you, I use the language of the domain experts.
I'm not sure about that. Let's take another example. Here, you're checking the completion. You're checking the completion of what?
Of the selected fares?
Okay. You don't see what I mean?
No.
Maybe there is a strong indication in the way you wrote your domain event there. Fare selection found incomplete, fare selection completed.
I don't see it.
Okay, so here you have a linguistic tension that comes from a salience bias, which is a cognitive bias that predisposes people to focus on information that are more prominent or visible. And what is the most visible concept here is the selected fare, so you based everything on that. But this is not the concept you're handling, actually.
Then what?
I will show you that. I will show you what you are, in fact, using here, but we have to talk about what you did after here, listing the ancillaries. So each time the user selected a fare, you have to list the available ancillaries on that fare. Ancillaries are paid options such as special meals. And then the user can select some ancillaries, and since there are paid options, we have to take them into account in the computation of the total price, along with the selected fare. So what total price are you computing here?
Okay, I see. Of the selected fares and the ancillaries.
Come on. So here you have a cognitive binding effect, right? It happens when the contextual association of seemingly independent concept hides a cohesive concept, which is here, the selection. So yes, so in fact here, having the selected fare and the ancillaries is the selection, and the action you have is actually computing the total price of the selection. But I would also say that in fact you are pricing the selection, and at the end of that flow, you have a priced selection.
I see.
If we go back to the completion checking, here, it's exactly the same thing. You're checking the completion of the selection. The selected fare is just an element of this selection. And at the end of these flows, you have an incomplete selection and a complete selection. So now, if we take a higher look, you can see that all these green models are different states of the selection. And you overlook that because of the way you wrote your events. And because of that, here you have an implicit life cycle tension. The life cycle of a concept, here the selection, is derived from the state of other concepts or from false cognates, such as here the selected fares.
I see.
So to fix this problem, what you need to do here is to create a new model dedicated for the selection.
Okay, that's an interesting approach to it, but it's not the only way, honestly. There is multiple ways of solving this, and my code is fine too for handling that.
Okay, so show me.
Well, Here, for example, is the commit where I first introduced the selection on top of the search, right?
Yes.
So I needed to know what fares of a ship were selected. So all I did was adding a quick boolean here, selected in every fare of every ship of the search, and that does it. I can know.
I can clearly see there's many model tensions there.
Really? How do you see that?
By using ancient elf magic.
Oh, ancient elf magic. How do you use that?
That's quite easy. So you go to the settings here, plugins. It only works with IntelliJ, but you look for ancient elf magic and you enable it.
Okay, I see.
And let the magic happen.
Oh, that's convenient.
It's not a real plugin. Not look for it. So here you thought it would be easier to add a selected boolean in every fares to handle the selection.
Well, yeah.
But in fact, you introduce more complexities than you resolve. I'm quite sure that the code using that boolean here is quite complex. Can you show me?
Not really, honestly. Look. So here in my search, all I'm doing is, for example, here I'm checking the completion of this selection. And as you can see, the code is quite straightforward.
I won't say that.
Why not?
Because here, to compute the fact that a selection is complete, you have to stream your ships. So stream is a kind of loop over for each. Yep. So you loop over all the ships. You loop over here all the fares to find the one selected. That's quite complicated. And I'm quite sure that you have to do that for every concerns related to the selection. So yes, here, computing the total price, you loop over all the ships, looping over all the fares to take only the one selected. And here, to select the fare that the user wants to book, you have to do exactly the same thing, looping over all the ships and all the fares again. So what you have here is a high friction for low complexity, which is a structural tension. The development of a trivial rule requires a complex, not straightforward implementation. And why you have that here is because you put the selected state in the wrong place. I will do another demonstration here. In that example, you have selected the fare, the first class fare, on the ship A on the outbound, right?
Yes.
What will happen if I'm going on the ship B on the same outbound, and I would like to select at the same time here this first class fare?
Well, you can do that. You can only have one ship that's selected per bound, and you already have the ship A selected on the outbound.
But exactly. But here, structurally, your model allows it, because you have several booleans in every fare. So what you have here is an extrinsic state infiltration. The fare cannot ensure the consistency of its selected state field here without being aware of the selected state of the other fares it should not depend on. And this kind of tension usually occurs when the state of an external concept, for example here the selection, infiltrates one of its subconcepts, the fare.
Okay, technically, I guess if my model was only JSON, you could have this problem. But as you may know, models are also behavior. And here, when I select a fare of a ship, I first check whether or not there is a selected fare before. And I turn this one, I set the flag to false on this one before I select the new one. So as you can see, I'm enforcing this consistency and there is no error.
Can't you see exactly the same problem?
Why?
Because here, you have a two-phase transaction in the search to ensure the consistency of the first internal selected state, which should have been an atomic operation. And you're so sure about your consistency logic here that I have seen something quite interesting in another part of the code. Here, when you check the completion of the selection, I'm seeing that if you have more than one outbound selected, you are throwing some exception. Why are you doing that?
It's just some extra safety, but this should never happen.
This should never happen? You sure? So why did you write it anyway if it will never happen? Because structurally, your model allows it. So you cannot be sure that in some cases you will have several selected outbounds.
So what you're saying here is that the very structure of the model should not allow representing a state that is not valid. So we could see that as a model tension, a not always valid model.
Exactly. And furthermore, checking the number of outbound selected and so on is not at all a concern of the search. That's a concern of the selection. So in fact, here, you just have a de-encapsulation of business logic, a diffusion of responsibilities, because the search implements an invariant that belongs to the selection. And all those things come from the fact that here, you have several fields dedicated for the selection everywhere inside your model. You have the selection completed here, the total price, and all these booleans. And once again, what will happen if here I'm turning this boolean back from true to false, the selected here? What will happen?
Well, you'll need to recompute whether or not the selection is complete, and you'll need to recompute the total price as well.
Exactly. So here, what you have is a disseminated representation, because some states here across multiple concepts are functionally correlated and often indicate the absence of an emergent business concept, here the selection. Determining the state of the selection requires combining multiple sources everywhere inside your model.
I see.
So what you have to do then is take your big ball of mud model here, and you look for all the fields that are required for the selection, and you create a dedicated model out of it. That way, you will have two simpler models, one dedicated for the search, another one dedicated for the selection, and they will be less fragile. But it will not only simplify the structure, it will also simplify the code, because here you will have an aggregate for the selection, and all the code you showed us in the selection, the search, will be here less complex. Because to select a fare, it's just one line here, as you can see. Compute the total price, you just have to loop over all the selected fare, not all the fares of all the ships. And to determine if the selection is complete is only a 3-statement code.
I see. So if I get back to the bugs that I had initially, right? It's because I added booking concerns later. Here I wanted to prevent showing ships that were departing in the past when doing a search. And this caused the issue because I had to handle the case where we already had some booked ship in this search. But in reality, when I was checking this, I was checking whether or not a search was actually a booking.
Exactly.
And we can see this from all the concerns that are disseminated across the search but are related to the booking. So what I should have done instead is look for every field that is used for the booking and externalize them inside of a booking aggregate. And it could be more focused on stuff such as the payment mean or whether or not it's finalized, while my search could be more simple and focused on search criteria, on its type, and so on. But more importantly, fixing this bug becomes really trivial because it's just that in case of the booking, I have to check whether or not it's finalized. But this finalized concept here, to make it emerge, we had to separate it into a booking aggregate.
Yes, and that way, when you will fix something in the search, you won't have any regression on the booking.
Nice. OK, I'll do that.
OK, but don't release your fix right now. I need to implement the same invariant on my side.
Wait, what do you mean? I feel like you need to always duplicate logic from my service. Why would you need to implement that?
Well, since you're handling the booking creation in the cruising service and we manage post-booking features, I assume it's quite natural that you have the feeling we implement similar behaviors.
And remind me why these features were not implemented in my cruising service?
Because the cruising model was a big ball of mud already.
Come on.
Implementing feature in it was taking forever, so our manager decided to create another team to handle important features, such as the exchange and the cancellation in a post-booking service, my service. And since this was a greenfield service, it allowed us to move much faster without breaking things.
Clearly, this worked well. I guess this is why we keep breaking each other. I have a hunch. I suspect that our respective systems actually form a distributed big ball of mud.
A distributed big ball of mud? Yep. Quite the overstatement as usual. You know, my service is a greenfield project, and my team follows best practices.
But as you just pointed, there are multiple implicit models hiding inside the search, right? Including the booking and the selection. And that's because my cruising service is not only handling the search, but also the booking, right?
Yes. What's your point then?
Well, my point is that our respective services are overlapping on this booking concern.
I won't say overlap, but I guess that some level of coupling is quite normal since my service is handling the post-booking, so everything after your work flows.
OK, it's more than that. Let me show you. You say that you have to duplicate the new invariants that I just wrote, right?
Yes.
And I can't help noticing that it's not the first time you have to do that.
Yeah, it's true.
It's a clear sign that business logic is leaking from my service to yours. That happens when behavior, invariants, lifecycle, and so on are scattered across bounded context. And I think we can see these business logic leaks as some kind of a model architectural tension.
You mean like a model tension, but across models?
Yep.
I don't think that's a thing. Maybe we're just missing some best practices on our side.
It's not about best practices. You will be constrained to duplicate logic on your side because, like I said, we're both trying to solve the same problem.
We're not solving the same problem. Look, You have the booking on your side, and on mine, I have aggregates for exchange and cancellation flows, and they are not the same thing.
Yeah, but I think there's another way to look at your aggregates. Here you could have named them exchange booking or cancelled booking. And I believe they're quite dependent to the state of the booking increasing as well, right?
They are. Because to allow a cancellation, I need to check if the booking was completed on your side, meaning the traveler already took the trip.
Exactly. We're just representing the states of the booking as different aggregates across our bounded context.
I disagree. Let me take the example of an e-commerce platform. Here, you cannot consider that the order and the parcel are different states of the cart. They have their own business logic and distinct life cycles.
But that's exactly the point. Here we have a single booking life cycle that's going through your service and back to mine. And we've already seen that we keep duplicating the same business logic in our aggregates. So what we have here is a fragmented life cycle architectural tension. When separate bounded contexts handle different states of the same aggregates while sharing many concepts, persona, and rules. And that's especially true as the lifecycle moves back and forth between services. Because of this, we struggle to determine what is the actual state of a booking.
It's not true. It's quite simple, in fact. Let's take the example of the mobile team. Whenever they need to check the status of a booking, they check first if it exists on your side and whether if this booking is superseded by an exchange or a cancellation in mine.
Yeah, and then they also need to check whether it's been completed in my service. We'll get there? Yeah. So, as you see, they need to make calls all over the place to figure out the actual state of this booking. Plus, you told me earlier that we shouldn't be able to represent a state that is not valid, right?
Yes.
But here, structurally, we could have a booking that is both completed and cancelled at the same time.
Oh, yeah.
So the states of the booking are literally spread across our services, which results in a distributed state architectural tension. And that's when understanding the state of a concept requires consolidating data from multiple bounded contexts.
So what you're implying is that, in fact, exchange and cancellation are not domains on their own here, but just state of the booking.
Yep.
And that would mean that we have multiple models trying to solve the same problem.
And it's actually even worse than that. They're not able to solve their scope independently because in reality, they are fragments of the same model. So as such, these fragments need to heavily interact with each other. An evolution in one fragment will necessarily impact the other, even if you try to consider them as individual models. So in fact, these models are coupled externally, which is why we can say that there is an extrinsic coupling.
Extrinsic coupling? I don't think my models are coupled to yours.
Okay, remind me why you asked me to delay the bug fix.
Because when you change something in the cruising service, it usually breaks logic in my post-booking service, and I had to stay overnight to find a remediation.
Yeah, and it's not the first time that it happens, right?
Yeah.
Can't you see we have frequent breaking changes, which is another architectural tension? When every model evolution breaks collaborating bounded context. We have model tensions all over our architecture, between the business logic leaks, the fragmented lifecycle, the distributed states, and the frequent breaking changes. Everything points toward extrinsic coupling.
Okay, so if I understand, when we created an outgrowth model to work around your sclerosis model, here, in fact, we were working on the same domain flow with the same constraints. As a result, we fragmented a single model across several services, which in turn caused extrinsic coupling. And the worst part is that this fragmentation results in business logic linking between systems, which reinforces the fragmentation. And so because of this extrinsic coupling, we ended up distributing every evolution across services, like I said, so they are constrained to evolve in sync.
Yeah, and since the workflows are distributed, every small synchronization error will end up breaking things, which makes our fragmented model fragile. Now, if anything breaks because of the coupling, both systems will fail at the same time. So because of this, we'll avoid changing the systems as much as possible to limit this risk, resulting in fragmented model rigidity. It's the same thing as with intrinsic tensions now. This rigidity will raise the system entropy. And in turn, this entropy will bind the fragments of our model into a distributed big ball of mud.
I'm still not sure about that. We no longer have that many breaking changes. We set up processes to prevent that.
But that's exactly it. we assumed that synchronized evolution were inevitable, which anchored them as governing constraints of our socio-technical system.
What?
Okay, what I'm saying is that our processes and organization are constrained to compensate for the synchronized evolution of the fragmented model. Remember when I added the travel insurance, for example?
Oh, yeah, how could I forget? You added a feature so people could book travel cancellation insurance in cruising, but when they canceled their trip in my service, it wasn't taken into account, making it completely useless.
Yeah, and users who actually paid money for that were not happy. I had to roll back my feature and wait for you to add it to your model. And then, when you were ready, we could both deploy, but we still had to deploy at the same time. So, the architectural tensions that we saw earlier are forcing us to synchronize our releases, which in itself is a process tension. That means that we can see signals of coupling between our models, even in the way that we work. So this happens when we have a necessity to synchronize heavily around releases and model evolutions across systems, which completely defeats the purpose of microservices.
That's true that it forces us to coordinate closely, plan ahead, and develop in next step, denoting an inter-teamwork coupling, which I think is an organizational tension. So when teams need to constantly synchronize their plans and priorities despite their scope of autonomy. So our model fragmentation led to synchronize every evolutions across teams and systems, which created tensions in our processes and organization.
Yes, and this need for synchronization is structuring the way we work, which is what I mean when I say that it turned into a governing constraint of the socio-technical system.
But I don't think we have this problem anymore.
Why not?
Look, when you added the support for special meal in your service, it would have broken my service and blocked your release.
Yep.
But you just use a feature flag to deactivate the feature, and you didn't have to freeze your releases while waiting for me. And once I was ready, we could just activate it together at once with no planning overhead and no failures.
Okay, that's true, but we still can deliver autonomously. And my code is just sitting there, producing zero value until you finish. So it's only a band-aid process, another process tension. So that's when unresolved design problems are compensated by processes such as multi-versioning, double run, feature flags, and so on to limit the impact on another team. Now, one feature flag isn't a smell, but we have 50 feature toggle. It's a process hell of its own. Managing this toggle is taking so much time that the organization decided to create a full-time role dedicated to that, the RTE.
The RTE?
Yep.
You mean the guy who keeps asking us if we are done with a feature to synchronize feature toggles?
Exactly. The readiness toggle engineer.
Oh, yeah, I see.
Unfortunately, this is a palliative role, which is an organizational tension. This happens when the growing complexity of band-aid processes and ceremonies require a full-time job.
In that context.
Yep. In our context, the very existence of this role compensates, it's just a compensation for the consequences of the extrinsic coupling.
Okay, so the intrinsic coupling here led to synchronized releases and inter-teamwork coupling.
Yep.
And we set up band-aid processes and palliative roles to buffer all these problems here. But in fact, these last things were only compensatory countermeasures offsetting process tension and organizational tension instead of addressing the root cause, which is the extrinsic coupling. And the worst part is that some of our compensations, such as the RTE role, actually becomes obstacle to fixing the root cause because we would no longer need the role if we resolve the intrinsic coupling.
And that's how an extrinsic socio-technical tension crystallizes. So when we compensate for a problem, this problem will create side effects, or this compensation will create side effects, for which we'll need more compensation, and so on and so on. So here we are forming a self-perpetuating system of compensation.
Okay, I see your point. Our processes and organization have been shaped by crystallized tension of extrinsic coupling. And we have been focusing on the work around the work, trying to fix our issues with processes and organization, when in reality, it was a design problem. Okay, I guess what I'm seeing now is that our stressing coupling manifests as organizational dysfunction.
What kind of organizational dysfunction?
You remember our endless discussion about where to implement the feature allowing a user to change a seat on the same boat?
Yeah.
We keep arguing whether it should be an update of the booking on your side or a creation of an exchange on the same boat on my side. I think this is the signal of an unclear ownership organizational tension. So when a need for a feature debugging or development arises, debates often breaks out to determine which team should be in charge.
Okay, so I guess that's why some concerns end up in the wrong place, which exacerbates the extrinsic coupling.
And because of that coupling, every time you have a new feature, you request a development on my side. I don't even have time for new post-booking features. You basically hijack my backlog.
Sorry.
So it's a backlog takeover.
And a hostile one at that.
I think it's also an organizational tension. Although I guess this is a strong signal that something was wrong in the design. It happens when the work of a streamlined team is systematically on the critical path of another team. My domain is becoming a crutch. It's supposed to be a core domain, but it's just like it's supporting yours.
Yeah, it's like you never developed a scope of your own. I was leading the changes on your side, which caused even more fragmentation. So essentially, that means that we had our model fragmentation, which led to synchronized evolutions that in turn shaped a system of compensations. All these things led to organizational fragmentation, which then enacts as a catalyst for even more model fragmentation. So this means that we have a self-reinforcing loop driving socio-technical entropy.
And this entropy does not only impact us, I think, even the user experience is affected. Remember when you added the seat preferences in booking?
Yeah. It was, users were frustrated because they couldn't select a seat when exchanging.
Exactly. And I think it's a business capability discrepancy, a business tension. This happens when a capability varies in scope, maturity, and behavior across the system, causing gaps and inconsistencies. Selecting a seat was only available on the booking side, even though from a business perspective, it's supposed to be a single capability for the user.
So it means that this entropy had even a business impact. It's kind of a shame we didn't see it as a wake-up signal.
So if we take a step back on what happened, you accumulated accidental design depth and your model sclerosed. And we created an outgrowth to work around your sclerosed model to be able to be much faster. And why we did that? It's because the management decided to create a new team to offload the work of your historical team, because you was not enough quick to develop anything. So it looks like, in fact, that our organizational fragmentation led to model fragmentation. It looks like there's something with the Conway's law.
Conway's law?
Yeah, you know, that law that says that organization produces systems that mirrors their communication structure.
Wait a second. So this means that management has been doing organizational shadow design all along, which is an organizational tension. When management unconsciously designs the architecture of the system via organizational decision, which means that it's all their fault.
Wait a minute, because on what they took that decision? Because your model was sclerosed, because you accumulated accidental design that they had no other choice.
Let's not play the blame game, okay? It's not individuals, it's a systemic issue.
Just like you did, right? But you have to keep in mind that organization will charge you interest on your design depth, and we will all suffer from that.
Okay, so that means extrinsic coupling signals are mainly socio-technical, right?
Yes.
So in the same way that for the intrinsic coupling, we could use the model tension heuristics to spot model tensions and prevent model entropy by acting on them before they crystallized, in the case of extrinsic coupling, we can use them to prevent entropy at the entire scale of the socio-technical system.
And to be able to do that, you need to build a case to highlight potential extrinsic coupling within your system. It will help you to assess its location, depth, and spread before it crystallizes.
And how do you do that? First, by detecting signals across the socio-technical system, then using heuristics to find symptoms among these signals, and collecting a body of evidence to explore possible correlation. And that's how we can use model tension heuristics to prevent accidental design doubts. But they're only heuristics. They're not surefire rules.
Exactly. Because they do not always reflect tension. Like in this example here, this is not a fragment in life cycle.
And that's why we also need to do experiments on the system. We need to have, once we have a full body of evidence, we need to act on the signals by running limited safe-to-fail experiments to test whether or not our heuristics were right on the given case. You can read more about this in this article. Oh, sorry.
Yeah, this is an article from Rebecca Worsbrook and Matthias Ras.
So in our cases, it's not that simple to separate the booking from the search, right? How should I go on and do that?
Yeah, it's true that you really see that there's perhaps many coupling and so on, but oh no, there is an iframe something error. But here you could see another talk from two other guys, us, on something called model mitosis. It's available on the channel of Domain-Driven Design Europe.
Yeah, okay. We plan on playing it for the next hour or so, but since it's down.
So thank you very much.
Thank you.
I'm Julien Topçu. I'm the CTO of Shodo, a consultancy company specialized in domain-driven design, software craftsmanship, and all socio-technical stuff.
And I'm Josian Chevalier. I'm tech coach at Shodo as well.
So you can scan that QR code to have access to the slides and a repository in which we put some model tension from that talk. Thank you very much.
Thank you.